Hello, everybody. Welcome to the first lecture of Fourier Series and Transform, in which we are going to talk about the fundamentals of Fourier. So one thing really important here, which is that a lot of students are missing out the details here because they try to perform a lot of operations with Fourier series and transform. However, they don't know the fundamentals. That's why they're struggling. But instead, you are here and I'm going to teach you the details. So first of all, Fourier series and transform is deeply related to real life because in real life, as engineers, our job is to analyze everything, and with that analyzing process, we need to manipulate everything. And we also consider everything surrounding us as either a signal or a system. That's why it is important to have a good understanding on what a signal is and what a system is, especially systems take signals as inputs and outputs. So, in this journey, one important question is this: how do you analyze signals? So, analyzing anything in the world is a hard thing, right? Analyzing. How do I analyze anything? So, one of the best ways is to decompose it. Because let's see, here I have a pen, a blue pen. If I know how to get this from the scratch, so that means that I could easily decompose it and compose it back for a later use. So I could, whenever I want, decompose it and, get it back in the old shape. I could do it whenever I want. So this is an important analyzing process, and the question is, can we do the same thing for functions? Because we know that signals are considered to be functions. I mean, let's just not say considered to be, but they are interpreted as mathematical functions. If we could somehow find a way to decompose signals to building blocks of signals, we could easily form them whenever we need, and we could easily deconstruct them again whenever we need. The magical word in here is construction. This is what Fourier series and transform is all about. The question is this: can we construct signals from a building block? And the answer is yes, we can. And those building blocks are actually going to be sines and cosines. Let me put it right in here with a better handwriting. Building blocks are possible in functions, and those building blocks are going to be sines and cosines. This is an important notation. So there might be another question in your mind: why sines and cosines, which I will answer in a couple of lectures. So we have these sines and cosines, but another question comes to my mind. So sines and cosines in general, sinusoidals have a lot of different properties. They have magnitudes, they have frequencies, they have periods and everything, angular frequency, phase. Or the simple question, is it going to be sine or cosine? That's also an important question. So how do we know if a particular function can be made by using sines and cosines? Actually, the idea is quite simple. Let's say we have an f of x. It's a general function. It could be anything in your mind. It doesn't matter. So what we're trying to do is we're trying to get this function by using some sines and cosines. Let's say the first sinusoidal could be in this way and the second one could be in this way. Let's also change the angular frequency in here. It could be in this way, and it goes on like that. But how do we know that particular constants and coefficients in here? For instance, how do we know what is the value of a1 or a2 in here, or omega 1 in here as the frequency, here also frequency, phase, another phase? And actually, that's the beauty of Fourier series and transform, because functions can come in many different ways and in many different shapes. So it is actually important and useful that we are going to have different sines and cosines with different frequencies. This is really important because Fourier series is a frequency domain operation. It's not about time. As human beings, we judge everything by time, which is not that useful, but we think that it is because we are actually not that powerful to sense the power of the frequency. We don't see anything in terms of frequency, we see everything in terms of time. But Fourier series is a tool where frequency comes in, because imagine you have a function like this. This is a function, right? Let's say this is f of x. How do you form this by using sines and cosines? The only way that you can do it is by, putting a lot of sines and cosines together. Because the idea is this. Let's say we have this edge right over here. See this edge. So in order to actually form that edge, for instance, we're going to use a cosine like this. And then since actually it has a little bit this shape in here, the shape in here is a bit weird. So we're going to have another sine, which is actually having this value in here. So let's say another sinusoidal signal, which is something like this, another sinusoidal, which is something like this. So when it comes to a point where we sum all of the sinusoidals in here at one point, in this vertical line, which became huge, by the way. Let's try it this way. This is also huge, but you got the idea. So here at an instant time, you're going to get the value of that function at that point. And Fourier series and transform is going to allow us to do these calculations and decompose or deconstruct any signal we want. This is the idea, and we're going to do it in terms of frequency. So what I come to notice in my 6 to 7 years in teaching signals and systems is this: most of the time, students do not have the mathematical background to deal with Fourier series and transform. That's why I'm gonna have a bunch of preparation lectures on Fourier series and transform. If you want, you can skip any lecture that is entitled as Fourier series and transform preparation. However, my suggestion for you is that you should not skip it. Why? Because sometimes there might be a little tiny detail which is going to save your life. So it'll, I guess, take 2 to 3 hours to complete the whole preparation section. I think you could actually take that time to, improve yourself a little. You could just do it in 2x or something like that. I don't know. I just want you to watch it. So if you're saying that you're fully prepared to go and move on, that's fine. You could move on to the next lecture where actually we are talking about the coefficients of Fourier series and transform. Basically, how do we get the equations? So these lectures are also important. So I'm going to end this lecture right at this point, and in the next lecture we're going to be talking about some basic properties of functions like period and also even an odd functions, which we are going to find pretty useful in the coming up lectures. So thank you so much for watching, and see you in the next one. And by the way, if you have any questions, do not hesitate to ask anytime you would like. See you in the next one.